Knowing that this is a right-tailed test, the alpha, which is basically 5%, is right here. Because it's a right-tailed test, this is 0.05. All the other area, obviously, is 0.95, because we know that the total area underneath has to be 1. Okay. We know that this is 0. Next, I would like to determine this number. We already used it many times, but let's determine it again. We used it because we calculated it, but we haven't really used it in problems. Okay, so I know that this distribution of z statistic, right, is 0, 1. And I would like to determine this number here. Okay, so inv norm, we want the area to the left to be 0.95. I want the mean 0 and the standard deviation 1. And yes, that's fine. I want left. And that number is 1.64. Where is this number coming from the sample? It's right here. It's a number greater than 1.64. Because this number is in the rejection area. We will reject the null hypothesis. And we have to write, there is sufficient evidence to conclude that P does not, that P is greater than, there was a right-tailed test, that P is greater than 0.50 according to this sample, to the data coming from the sample. There is sufficient evidence to reject the null hypothesis. There is sufficient evidence coming from the sample to conclude that the proportion has increased. Now, finally, I want to talk about the p-value. What is the p-value? The p-value, and I'm going to graph it again. This was number 1.64, but this is somewhere here 2.15. This is the p-value. This is alpha. All this area is alpha, everything. You notice that the p-value, this area, is definitely smaller than alpha. Every time the p-value, this area in other words, or probability if you want, is smaller than alpha, we always reject. We always reject H0. Because this data coming from the sample is telling us this. To reject, it's in the rejection area. It's not in the non-rejection area. If it happens that Z statistic is here, or here, or here, then I will have to fail to reject. There is not sufficient evidence to conclude that this has changed. But it happened that the data coming from the sample, what the Z statistic or Z nod, if you want, was here. Because it's here, the area to the right, the p-value in other words, is less than alpha. and therefore we reject H naught. Let's do this with the calculator and then with StatCrunch. So let's go to stats now and go to tests, please. And scroll down to 1 proportion Z test. Number 5, 1 proportion Z test. Okay, our P0 is given in the problem as 0.5. Our X, number of people who said yes, was 534. Total number of people who in the sample, 1,000. Now we have to select the type of test. As you see, we have 3 tests in the graphing calculator, as we have always. Not equal to, less than, or greater than. But our test is a right tail test, so we have to use this. So make sure you scroll to the right, go over to greater than P0, press enter, make sure it's highlighted. What I would like to do, I don't want to calculate. I want us to draw, because the draw gives us everything, including what we are looking for. So look what happens. 1 proportion Z test, it gives us this test statistic. Here that is 2.15, even with more decimal digits than I wrote here. It also gives us the p-value. It calculates the p-value. How did they calculate the p-value? They calculate the probability to the right of Z0. And it happens that it's under 0.05. Because it's under 0.05, then we reject H naught. Now, if you say, well, you chose alpha to be 0.05. Well, what if you choose alpha? What if you choose alpha to be 0.01? Your p-value is 0.0158. But now, alpha is not less than p. I meant to say p is not less than alpha. P is greater than alpha. Look at this. So this is not the case. This is the case. This is correct. What do I conclude? Well, if I want to use this level of significance, then I will have to say fail to reject. Fail to reject. So this is, remember, this is the probability of making a type 1 error. And it depends on what alpha is chosen to be. So the decision changes. Now, if you try to go back and just calculate, it's the same thing. It gives you the p-value with more decimals. It gives you the z-value. It gives you p-hat. It gives you n. But I prefer to select, it doesn't matter, it's up to you. I prefer to select the graph and the draw because I can also see it. And it's highlighted. It's colored in. If you don't have colors on your calculator, it doesn't matter. It will shade it in anyway to show you the p-value. Any questions? So it all depends on alpha. Any questions? Go ahead.
Yeah, every time I do the one prompt test, it says error, like dim mismatch. What's this? Could it be like that? My window's not in a standard mode, or?
No. It shouldn't be. So you have an older calculator. So you go to stat, right? And you go to go across to tests, correct?
Yeah.
And you're using 1 proportion Z test.
Yes.
Okay. And then what happens?
After I do all of this?
Since I cannot, Ramona, since I cannot see it, so tell me what you wrote for P sub 0.
0.5.
Okay, perfect. What did you write for X?
534.
Good.
534.
And for N, 1,000?
Yes, 1000.
Did you choose the right tail test?
Yes.
And did you click on draw?
Yes.
Can you bring the calculator closer to the camera so I can look at it?
It says this.
Yeah, but before, show me before.
Okay.
Yeah, show me this the what you before you clicked on enter. So you have calculate and you have draw. Do you have this should not affect anything. Do you want to go to second and stat plot? Do you want to go to second and stat plot? And can you make sure that all the stat plots are off? Maybe, but it should not have any influence.
Let's see.
So all of them should be off, but I don't think it should make any difference. They are all off?
Yeah.
Okay, can you try again?
Okay.
I don't understand why it's giving you that. Did it
Okay, now it works.
really?
Yeah.
I'm a genius. I'm a genius. I'm a genius. But I have no idea why. So I'm not a genius. I have no idea. It was just a hunch, but I have no idea why it worked. I don't have any idea.
Thank you.
My pleasure. I have no idea why it didn't work, and I have no idea why it works right now. Okay, with a calculator, I would like now to find a 95 confidence interval because I want to talk about the last item here. So let's go to tests again. And we want one proportion Z interval. Part A in my calculator anyway. Item A, one proportion Z interval. And we have 534, which is X. We have N, which is 1,000. And we want the confidence interval of 95, so 95. And now calculate and press enter. So here is the interval that I got. So 95% confidence interval, 0.50308, comma, 0.56492. So coming back to our conclusion, at a confidence at level of significance of alpha 0.05, that's what we did. We got that the proportion, what was it, 0.53, 0.53, 0.53, 0.534. 0.534 is in this interval. So p hat 0.534 is in this interval at 95% confidence interval, right? But this means that alpha is 0.05, but this is, as you know, two-tailed test. So if we want to look at a one-tailed test, so p hat is in this interval. If it is in the interval, we fail to reject. But remember, we had alpha 0.05 in one tail. If it's this 0.05, then on this side is 0.05. So that means that I'm looking at a 90% confidence interval, not 95% confidence interval. So let's see what happens now. So this is what we did when we rejected a null hypothesis. So let's go back and just repeat with the same thing. one proportion z interval right here, and just change that 95% into 90 and calculate. So with 95, just checking my calculation one more time, one proportion z interval. 534, yes. Okay, so 0.50805, 0.55995. And that is a 90% confidence interval. Okay, any questions? Any questions? Any questions?
Nope.
Would you mind centering the paper?
Sorry. Thank you. Five and 5, 90%. I also want to look at 80%. One proportion z interval and calculate. That's another one. We can always go back and determine other confidence intervals. Okay, moving on. So now we know what the p-value is. The p-value could be smaller than alpha or alpha over 2. Because if we are going to, and we're going to look very in a moment at a two-tailed test. So when you look at a two-tailed test, let's say if alpha is 0.05, this area is half of it, which means 0.025. And this area is half of it, 0.025, for a two-tailed test. And now the p-value has to be less than alpha over 2 to reject. Has to be here, anywhere here in the rejection area, or anywhere here in the rejection area. But as a probability, it has to be lower than this number, which in this case represents alpha over 2. In the previous case, for us, it represented alpha, the entire alpha, because this was a one-tailed test. But when we talk about a two-tailed test, and we'll look at an example in a minute, then I have to worry about alpha over 2. Moving on to the next one. Okay,